Well, hello folks, my name is Barry McDade. I'm the Automotive Technology Training Manager for WorldSkills UK, and I've been asked to provide a short video just to say how we've been using virtual training to deal with the circumstances we're in at the moment. So really the question is, how do we go from what we were used to, which is here our Back to Basics training, which was held in Northwest Regional College, working on very real faults in engines and workshop conditions, to what we're presented with today, which is a virtual learning and virtual training. And how we've been dealing with that is we've been using simulators by Electude, which is a simulator program on a vehicle, which provides options of doing various tests and component testing, component replacing, which simulates what we actually do in the workshop. In this instance, the vehicles can be started, can be ignition, can put in different places. Components can be removed. Those components can be replaced if you so decide. Different components can be removed, replaced, and it's a very good program. Back on. You have a range of tools. So you have your multimeter, an oscilloscope, a diagnostic tester. You also have breakout box, which can be connected into the ECU. Fuel pressure gauges, which can be done for practical mechanical testing. Jump starting if it's needed. Wiring diagrams, which is essential. We also introduce into manufacturers wiring diagrams too, as well, to align with it that we're doing. An example that we can be using for today is how we measure and test the accelerator pedal position against the air metering sensor. The accelerator pedal position, it's a fairly simple sensor. As the accelerator pedal is depressed, there's a voltage signal sent back to the ECU, the engine control unit or power control module, and it relays the actual position of the accelerator pedal and thus the actual physical demand of the driver. And then this input then is used by the ECU to regulate, for example, the throttle and to regulate fueling. And at the same time, we have a airflow meter or airflow sensor. And as the airflow increases or decreases, there's the sensor senses the amount of air. There's actually a heated wire element inside it. It's located inside, and the voltage and the current that's used to keep the wire at a fixed hot temperature alters by the air that's actually going across it, and therefore the ECU senses that. And there's a direct linear relationship between both sensors if everything's working. We have our oscilloscope here, so reading the wiring diagrams, our competitors will identify the components, see which wire's doing what, and we train them, and they are skilled technicians. They know what the relationship of each wire and how the sensors work, and they would know that there's a signal wire received back to the ECU. So if we set this up, where would we look here? So wiring I'm slightly to the side. And here we have the throttle potentiometer or accelerator pedal position sensor that we talked about. This is our oscilloscope, which measures voltage over time, so we actually see a pattern, and then we can actually attach this here as well. So effectively what we've done here, we've affected our oscilloscope, which is measuring voltage over time, to our accelerator pedal position sensor, and also our airflow, which is the driver's demand and the actual air being drawn in by the engine. And we start this up. Channel 2 on as well. It's on. And channel 1. And then if we accelerate, we see the direct relationship between the two of those. We also have our code reader here, which we identify, and we can read faults. And there's certain, it is a competition, so there's certain procedures and processes that you're required to do in order to get scores, to get marks within the competition, and it allows you to practice those processes as well, like reading the fault codes and then erasing them. This vehicle has been set up that there's no faults. It's actually for testing and for looking at, and you can see here there's a direct relationship here between the accelerator pedal position and the air being drawn in, and they should be exactly linear as that is. We also would tie this then to actual ones that we would take in the workshop, readings that we've taken in the workshop from actual oscilloscopes that we use. And here you can see this is a reading that we've taken from the airflow meter. You can read the voltage at 0 volts. You turn on the ignition, half rev, and then you go to full throttle. And when it works correctly, it should be up there. You can see 4.3, approaching 4.5 volts. And then this is red lines measuring the current coming across that sensor as well, and that reading vehicles. So we can tie those. The simulator works very well tying those together. And then, as I say, the competitor can practice this. And once we've given some training on all the many different sensors and actuators, and the actuators that if we use for fueling or ignition or EGR and different functions, we then can set faults into the vehicle and present them to the competitor to challenge them and to hone their skills. So if we take a wee look at this one, so this is one now we've presented a fault with. I'm not sure. We just take these wires off, and it's important to understand that this would be presented to the competitor. A vehicle is presented with a series of per performance, and find the faults and repair them as required, indicating to the judge or the assessor. So, and there's a lot of training and purposeful training that goes into process and how the actual competitor comes about and carrying out these tasks, because a lot of them will be very compound and very complicated, and it takes a lot of training and skill, and also practice, because practice removes a great deal of that nervousness, and also developing your knowledge, because the more you know, the less you have to fear in what you're doing. So in this instance here, we've put in some faults. So if we start the vehicle, we'll just turn this off for the moment. So the vehicle has started. And presenting some intermittent faults here with the engine management light on. So raise all faults, identify the vehicle. Again, this will be a part of process, and then reading the fault codes. And with different sense here, it'd be expected you raise the faults, and then this indicates then it's airflow meter, mass volume, oxygen sensor, which senses the oxygen going out the exhaust, and the competitor would know these systems are interrelated, and then he would have to try and confirm some of his faults. What also allows you here is you can go to control modules, systems, and you can also read live data as well that's coming off. And then using in this instance, we were using it for oscilloscope training. So in this instance now, it would be the same test. Those faults will be indicated to the competitor type of components he needs to be checking. So there's the accelerator pedal position sensor. Here we have the airflow, and you can see we have our battery connected here. Oh, here we go. Okay, we're set up okay, and it's using the tools correctly as well, which is very good, because there's variance here The voltage can be changed. Time scales can be changed here. If they're not correct, it can give all sorts of readings. So it's the practice of that. And here in this instance now, we can test. It's the same test. And if we hold, we can turn this vehicle off. And the computer would be trained that they would recognize if, well, they could see the linear relationship is the same, so which is good. But what may be noticed here is that this airflow meter here is not reading up. So there's 2 volts per section, so there's 2, possibly just over, just under 3 volts there. And we've been comparing that to readings that we would have taken in the workplace. So there was a good reading. Well, this originally was the reading we looked at. Where we were reading up around 4.39 volts. Nice sharp pattern, and as I say, this is from real vehicles, whereas this is a faulty sensor, and here you can see that it's only about 3.6, which aligns very much with what we're saying here. And the computer would be trained that he would identify that there is a faulty reading, that either the sensor is a problem, and within competition he couldn't just pull out the sensor. In reality, in the real world, he could possibly pull out the sensor and replace it, but within competition he'd have to justify and to explain why it is that he's looking to change that sensor. And his next step there would be if he was to go to the wiring diagram. So he's testing here at this point. He would now want to be testing at terminal 30. Pretty sure it says 30. Yes, here, and he would be expecting to get the same readings if the sensor was not faulty. Or sorry, if the sensor was faulty. Now if he was getting a different reading here at the ECU than he was getting at the sensor, well then that would indicate that there's possibly a fault in the wiring. The simulator also allows us to change these faults, put them in, place this part, and confirm diagnosis. So what we could do is now test this again. Oh. I got it. We can see now we're slightly higher here. Again, you can see that linear relationship, and you can see that the voltage has increased. I think also we'd be starting to use live data. See the light is out. Fault different reading is confirmed. And we have no fault codes. So in this instance, he has correctly used the correct diagnostic process to confirm the fault and repaired. And this can be done for over a whole wide range of faults here within these simulators that works very closely to the actual real life diagnosis that we would be doing. Thank you for your time, and thank you for watching.